So here are the notes for 621, implicit differentiation. So you should have gone through the Desmos already and kind of discovered what the idea behind implicit differentiation is, which is really just the chain rule. It's the idea that when you take the derivative of a function in this, or actually with this implicit differentiation, a lot of these are not functions, but the function rules still apply. So you'll hear me say derivative of a function, but they are not necessarily passing the vertical line test. So I mean the derivative of an equation. So when you take the derivative of an equation, you have to take the derivative of the inside times the derivative of the outside using the chain rule. Because you're basically saying that y in and of itself is a function. So we have to use the chain rule. So for example, the derivative of y squared is the derivative of the inside, the derivative of y, which is y prime, times the derivative of something squared is 2 times something to the first. Oh, that's confusing. That's a little one. I didn't even need to write that. So this is 2y times y prime. So just basically, anytime you take the derivative of y, don't forget to multiply by y prime. Okay, it's as simple as that. That's what implicit differentiation means. Don't forget to take the derivative of the inside of the function. And since we have a function within another function, we have to use the chain rule.
Okay, so I am going to attempt to make this video while there are students in my room, so you're going to hear voices in the background. Okay, so we are going to figure out where this function has a vertical tangent. So just to remind you what a vertical tangent looks like, if I have some sort of function and I have a vertical tangent line, it would be when your slope is undefined. Okay, so it's not a slope of 0, it's a slope that is undefined. So let's find the slope function and see where our slope function is undefined. I swear, everyone started talking louder as soon as I started making this video. Okay, so first thing we're going to do is find the derivative, and we are going to have to use the implicit differentiation. So to take the derivative of 2y cubed, use the power rule, that's going to be 6y squared, and you have to use the chain rule times the derivative of y, which is y prime. Okay, so use the power rule, but also every time you take the derivative of y, you have to use the chain rule. The derivative of x is just 1. And then the derivative of negative 3x times y is, you're going to have to use the product rule because it's x times y. So be careful whenever you have like a product of x's and y's together, or x's together, or y's together. If you have any sort of product, you're going to want to use the product rule. So the derivative of negative 3x is negative 3 times y, and then plus the derivative of y is y prime times negative 3x. So remember, it's f and g. F prime is negative 3, g is y, and then g prime, the derivative of y is y prime, and then f is negative 3x. And then the derivative of 6, don't forget, it's not 6, it's 0. The derivative of any constant is 0. Okay, so let's go ahead and keep our y squareds on the same side. Okay, because again, we are solving for y prime. We are solving for the derivative, the slope function. So we're going to subtract 1, and we're going to add 3y to both sides. Okay, so we want to keep the y primes over here, but we want to get everything else on the other side. So we're going to subtract 1 and add 3y. Make sure, by the way, as you're watching this, you understand every single step, and go back and rewatch if you need to, or do the steps yourselves first to make sure that you actually understand this. Okay, so I have y prime in 2 terms. So what if we factored out a y prime? That would get the y prime by itself. So then I'm left with 6y squared and then a negative 3x. And then my last step for solving for the slope function is divide by 6y squared minus 3x. 6y squared minus 3x. Y prime is equal to negative 1 plus 3y over 6y squared minus 3x. Now I want to point out, if you were to solve this yourself, it's possible you would have gotten 1 minus 3y over 3x minus 6y squared. So all that would happen is you multiplied every single piece by -1. So this might come up on your homework or worksheets or whatever, that your answer looks different than the actual answer, and that's okay. Just make sure if you were to multiply every single piece by -1, every single piece, not just some of it, every single piece by -1, if you get the answer that matches, then there you go. Okay, now we're figuring out where we have a vertical tangent. So remember, that's where our slope function is undefined. So when is a number undefined? When you're dividing by 0. So if we set 3x minus 6y squared equal to 0, that would give me an undefined slope. Okay, so let's go ahead and solve this. I get 3x is equal to 6y squared. Divide by 3. X is equal to 2y squared. Okay, so what does that mean? That means we need to figure out where x is equal to 2y squared on my graph, so I can find the actual point where this occurs. So I take my original function, 2y cubed plus, and instead of x, I can plug in 2y squared. Again, I'm using the original function. Once I use my slope function to come up with some sort of equation, I can plug that into my slope function and solve for the actual point. Okay, so this is a very common test problem where you have to plug an equation into the original function to solve for a point. And I get 2y cubed plus 2y squared minus 6y cubed is equal to 6. Let's see, that's going to be, 2y squared minus 4y cubed is equal to 6. And you could, it's not nicely factorable, unfortunately, but you could use synthetic division to test numbers, but you can probably see already that -1 will work. Oops, -1, because -4, if you make that a +4, right, by multiplying by -1, +4 plus 2 minus 6 is equal to 0. But I'm going to go ahead and just use synthetic division to double check. -4, multiply, add, multiply, add, multiply, add. So it checks out. So this is going to be y plus 1. So I'm kind of going through this quickly because this is like the algebra part that you should know from algebra 2 or pre-calculus, times -4y squared plus 6y minus 6. So that's y plus 1 times 2. Actually, let's pull out a -2. 2y squared minus 3y plus 3. And then the rest of this is this factorable again? If I plug in -1, no, it's not going to work. Okay, so I get y equals -1 here. So -1 is going to give me a y value where my x is equal to, a y value where if I plug in -1 into this equation, so going back, so plug in -1, I get x is equal to, I'm just going to have to take up more room here, sorry. X is equal to 2 times -1 squared, so x is equal to 2. So at the point 2, -1, I expect to have a vertical tangent. So what I'm going to do is I'm going to double check by plugging that into my slope function. If I were to plug it into my slope function, I would get 1 minus 3 times -1 over 3 times 2 minus 6 times -1 squared, which is a number divided by 0. A number divided by 0 is undefined. So at this point, I have an undefined slope, which is a vertical tangent.
Okay, now for the second example, you should recognize this notation. We're finding the second derivative. So that's just the derivative of the derivative. So I'm going to find the derivative first. The derivative of 3x squared is 6x. Easy enough. Derivative of -4y squared is -8y, right? But don't forget to multiply by the derivative of the inside because y is a function. This is a function within a larger function. So you have to use the chain rule. And then the derivative of 18 is 0. So don't forget to use the chain rule when you take the derivative of y. We're going to solve for y prime here. This one's a little bit easier. We're just going to subtract 6x. Times y prime is equal to negative 6x. Divide by negative 8y, we get y prime is equal to negative 6x over negative 8y. Simplify that is 3x over 4y, or 3/4 xy, x over y. So that's y prime, but this says find the second derivative. So to find the second derivative, I need to take the derivative of both sides. The derivative of y prime is y double prime, which is what I want. And then I need to take the derivative of 3x over 4y. So if I'm taking the derivative of 3x over 4y, I'm going to need to use the quotient rule. So remember, this is f, this is g, f prime g minus g prime f over g squared. So derivative of f is 3 times g minus the derivative of g, which is 4y prime. The derivative of y is not 1. The derivative of y is y prime. Anytime you take the derivative of y, you should have a y prime left over. So derivative of 4y is 4y prime times f over g squared. So I'm going to simplify this a little bit really quickly. So that's 12y minus 12xy prime over 16y squared, because it is 4y all squared, not just 4 times y squared. Now, what's interesting about this is you see we have a y prime left over. That's actually not okay. We are not allowed to leave y primes in our y double primes. But we already know what y prime is. Y prime is equal to 3x over 4y. So with second derivatives, you are going to need to use substitution. So y double prime is equal to 12y minus 12x, and then y prime, again, was 3x over 4y. And that's because when we took the derivative of y, the derivative of y is y prime, and y prime is 3x over 4y. So we do have to use substitution on this. And of course, you can simplify this. I'll do that really quickly, although it's not totally necessary. 12 over 4 is 3. So 3x times 3x is 9x squared over y divided by 16y squared. And on a multiple choice, they'd probably even simplify further by getting a common denominator of y squared by multiplying the numerator by this one by y over y, this one by y squared over y squared, and then dividing out the 16y squared. But again, you don't really have to worry about that unless it's multiple choice, in which case you are expected to know algebra. So big thing here with the second derivative is just start by finding the first derivative. I had to use the quotient rule in this case. Don't forget that the derivative of y is y prime. And when you have a y prime that sticks around, you do need to use substitution. And just substitute what you already solved y prime to equal. And there you go. That's finding the second derivative using implicit differentiation.